Okay, so let's see. Okay, so people have something resembling this. So let's walk through it for those of you who might be a bit confuzzled. What's the charm? What is it? Confussed? Well, Harry Potter. Confundus? Confundus? Yeah, the spell. I want to say confudulous, but that's not it. Whatever. It's been actually a long time. I used to watch Harry Potter every winter, but I haven't been doing that. It's just the music, right? Do 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 do. That and well, no, that's about it. Anyways, you guys don't care about the stupid movies I watch, but you will be tested on it. So, okay, so in main I declared int A, B, 5, 6 respectively. I pass in the address of A and the address of B, and so for A 9240, for B 9244. So throw these here. We invoke the call to swap, which has two parameters, which are both pointers, so we know those take addresses. These are stored within those variables. Boom and boom. That makes sense. I declare a local variable temp. I dereference PA, which goes to 9240. I get the value 5 from that memory location. I assign that to temp. I dereference 9244, which is 6. I assign that to the memory location at 9240. So 6 goes to what is A. I take what is currently in temp and pass that into the memory location at address 9244. So effectively 5 goes into B, which resides outside this function. So boom. And this effectively swaps those variables as we would expect. Okay, so let's take a look at a incorrect implementation, right? And so the only difference here is that instead of a integer temp, here I declare a temp pointer and I use it in a way that does not satisfy what we want to achieve in terms of behavior of the swap function. Let's step through it. Same declarations of everything else, so the setup is the same, 5, 6. The formal parameters for a swap are the same, both are pointers, and so I pass in the addresses to those pointer variables at this stage. Boom, boom. And so I declare an integer pointer temp. Where's that? There it is. And so again, it's garbage values at this stage until I go here, in which case well here, this is fine because I'm grabbing the value 5 effectively, right? I go to the address 9240, I take the value 5. So this right-hand side is 5, but where am I placing it? Wherever this is. This is an address of something, so I'm putting 5 there. Is this desirable behavior? No, right? Because I don't know where this is. This is nowhere within my program, right? And so this clearly breaks things. And so get the thing stored at 9240, which is 5, and put it at this location, right? Which my cat pictures, right? Or my noodle pictures. Noodles, get some pho, get some ramen. I'm what? I love making pho. Are you judging me for liking pho? Pho's great. Pho's great. I'm sorry? Well, the thing is, we hope that this crashes because we're trying to write this value 5 somewhere, wherever this is. I just don't know where it is. The likely case is that the operating system will recognize that you're going someplace that's not allocated to your program, and it'll just shut it off. That's what we hope to have happen. Otherwise, this might write something in some array you have allocated already. We don't know because it's undefined behavior, but typically when it crashes because the operating system caught the fact that you don't know where this is. But that's the best case that it crashes. Worst case is that it actually wrote something inside one of your other member variables, or other variables, I should say. Because I don't know where this is. You don't know where this is. Anyways, that's that. Again, so this had to do with the fact that I declare a pointer in which I did not initialize its address to something. And so I try to dereference garbage values. Go ahead.
Initialize that pointer to
Well, let's see. So, well, no, because it's if I initialize it, say to, well, that's kind of weird. I mean, it's so let me go ahead and see what I can do here. Let's play with this for 2 seconds. It would have effectively been the only way I foresee this working is if I declare int real temp temp equals address temp real temp. Right, I think this is the only way that this would work. Right, because I need some memory location to store the value 5. Right, so I'm storing it in this real temp, and then I'm getting what's here. But effectively, that's the same thing as just using real temp, just getting rid of temp altogether, right? And so this is the only way I can see this. Just having an actual memory location that stores integers to use. I don't have that yet with what we see in the slides. So anyways, that's why this doesn't work. There's 2 other implementations that don't work. I'm going to leave that to you to work through on your own as a study tool. So go ahead and do that. So I'm just going to blaze through it really quick. Wrong solution number 1 or number 2. Look through it. You have questions on it, go ahead and ask me. Well, anyways, just one more, sorry. Because I want to get to this. This is a bit more interesting than all that. If any of this is interesting, this is one of the interesting topics. So arrays and addresses and pointers. So here is a declaration of an array. I initialize, well, we see S3 here. I mean, actually, if you remember anything about syntax for arrays, you actually don't need to indicate the last array bounds if you indicate how many elements are there. It sort of infers, right? But although, I mean, with that being said, if I put 10 here, if I allocated 10 integers, this would only initialize the first 3. The other 7 would be garbage values, okay? Just bear that in mind, has nothing to do with our current discussion. But anyways, so here's an array nums, 3 elements. Let's go ahead and deal with this, right? And so just like any other variable, I can get the address of this array. Well, first of all, what does it look like in memory? Boom. So there's nums. We know that the elements, well, first of all, I mean, you might not know it. And so I'll state it as a fact now. When you declare an array, any array, all the elements are contiguous in memory, always. Okay? In fact, that is the reason behind why it's so fast in terms of access and reading. Reading and writing is the fact that we know where these memory locations are. They're right next to each other. Okay? That'll become a very important factor in terms of analyzing our data structures for performance. So there it is. And so when I see out address of nums, what do you think we should see at the console? Yeah, 9242, the lowest address corresponding to the structure, 9242, which is what we get. And so no mystery here. Everything's as we expect. So how about this? What if I don't provide the ampersand and anything else? I just call the name nums by itself, which is the handle or the identifier for this array. What do you think we get? It's a trick question, but I want to see what you had. Well, so it's true, there's no index, and so certainly we don't see any of these things. But it turns out it's something that's hard-coded with, it's part of the language. It turns out that when you refer to an array by itself, a static array, compile time array, you get the address. So for static or compile time arrays, getting the address or just calling the name alone is the same thing. It gets you the address of that array. It's something you just have to remember. It's a weird quirk of the language. Boom. Right? You simply write the array's name without the brackets, and C++ will give you the array's address. That's part of the language. Right? It's just something to memorize. Okay. So here's how we can make a pointer point to an array. Well, I mean, we can sort of, given what we see here, we know that pointers store addresses, and so we presumably whatever we assign to a pointer must be an address. We see 2 ways of doing the same thing here, right? And so I can certainly declare an integer pointer that points to nums. Well, nums in and of itself gives us what address? Yeah, 9240 because of this, right? Because the language dictates that the name of the array is the address. So this is one way to have a pointer PTR point to the beginning of that array. Or I could have used the ampersand, right? That would have provided the same result. Boom. And so nums, nums is an array, and so one way to recognize that is the address is itself, whereas a pointer is not the same thing, right? Because pointer, yes, it could store the address of an array, which is what we see here, but if I do ampersand PTR, I don't get 9240. What do I get? Yeah, 9256. Right, so this is one distinguishing characteristic between arrays and pointers. Yes, you can have pointers point to arrays, but pointers have their own address, as opposed to arrays, which they are their address, essentially. And also, the size of the array must be known at compile time based on all standards. Yeah?
So the address of nums and the address of the first element of nums?
Same thing. Same thing. Yep.
They're the same.
Correct. Same address. Yep. Yeah. So this leads to some very interesting things we can do. I could go to this element and get its address, or we'll see. I'll show you some strange syntax that it's just playing with the code. You really shouldn't do it, but you'll see in a second. But that is the correct way of phrasing it. Okay. So let's move forward with some of this foolery. Right. PTR is just a pointer. All right. And so that's what we observed in terms of what we just talked about. Right? Nums is just an array. It holds 3 regular integer values, but it doesn't hold an address like a pointer does. Okay, so in C++, a pointer to an array can be used as if it were the array itself. And so what do I mean by that? So here's the same setup as before, what we had in the last slide. So I can do this, and what do you think this will print out to the console, presumably speaking? Yeah, so the third element in the array it points to, which is 30. And so how do we interpret this, right? And so since PTR points to the top of the nums array, it prints out the value that is 2 elements down from that address. And so what does that look like, right? And so PTR is 9242, and it looks like there's something going on here in which I actually go to that address, or dereference 9242, which takes me here, and I drop down 2 elements, 1, 2, and obtain that memory location. Does that seem like a reasonable step of operations? We'll decode this and actually see what it looks like, but just developing the foundation of thinking here. Right? And so what happens when I do this? What do you think? Well, first of all, PTR is 9242, and this is dereferencing that address to grab that memory location. Yeah, so this will give me 10, which would have been the same as doing what here? Putting 0 here, right? Okay, so there's some weird things going on here. So it's the same thing as num 0 or 10. Okay, so what about this? So I start at PTR, I add 2 to it. So this is kind of weird. So I start at PTR. PTR is 9242. Now, by adding 2 to this, it might be reasonable to think that this computes out to 9244. You might have thought that. It turns out that's not the case. In C++, when the compiler sees an address with some arithmetic with an integer, it assumes that you're dealing with whole number of elements. Right? And so when it sees +2 here, it recognizes that PTR is a integer pointer. And so it assumes that you mean to say that I'm shifting down 2 integers and getting that memory location. Right? So it does this byte arithmetic for you. And so it starts at 9242, it shifts down 2 integers, and then the asterisk is the dereference symbol, which means I do what to this address? Yeah, I get the memory location, which is 30 here. Do you guys see that? Is the logic clear? The steps in which we took to get here? Which, if effectively speaking, did the same thing as this. Right? This got me 30, this gets me 30. So in terms of what we see here, we know that this is the dereference operator. What do you think the square brackets is doing for us? Well, the 2 is the index, but square bracket seems to behave like the asterisk, right? In that it's dereferencing whatever address I'm offsetting by. Okay. Question or just sort of? Okay. Yes.
So the array itself is like an address already, right?
Yeah. That is true. This nums is an address. It's in this case it's 9242, but you could also get its address in other ways. But anyways, it's weird. I know. Yeah.
Sort using the bottom one?
This? Yeah, you can do everything here as you would here. They're identical in every single way. All right. But yeah, you can sort this way. You can sort this way. But besides the point. But yeah, I'm just pointing out that there's 2 ways of doing it. But you know, you probably use this syntax. In all honesty, this is just being silly. But okay, let me actually point something out. So if I wanted to sort of have this line have the same form as this, what would I need to replace this number by? 0, right? So this is the same thing as this if I put 0 here. Do you guys see that? Just more weird stuff. Anyways. Okay, so print out the item that is 2 elements below PTR, or the address stored in PTR, and then dereference it. Okay. But anyways, this is besides the point. Nums of 2 is the same thing as p sub 2 in this case. But not always. We'll see some weird things that we can do with this particular facility in a moment. But anyways, I think you all get this. Okay, and so there's 2 syntaxes that have identical behavior, right? And so this idea of going down the jth element, getting the jth element, or moving down j elements and then dereferencing that memory location, these are equivalent in every single way. But use this, please. Use this. Don't use this. You can use this. In fact, I'm going to have you go through some problems just so you can understand the concepts, but in practice, use this, right? Okay, they both mean go to the address in PTR, move down some number of elements, j in this case, dereference to get the value, or write to that memory location if that's what you're doing. Okay, anywho. So again, there's this weird thing you don't need to know for this class. If you take a computer architecture course, they'll talk about, they do the byte arithmetic for you based on the type of the pointer, right? It knows how many bytes to jump down based on your type declaration here. But all that's done, that's handled for you. So it's going down j elements, not j bytes. Okay, so let's check out this example. Here I have a function called print data. It takes in an array. This is just another syntax for passing in arrays. At this stage, well, I'll talk about that later. And it looks like I'm printing the first and second element relative to this array. Here's my nums. In main, I declare a nums array, 10, 20, 30. And I'm doing some things here with regards to printing it out. OK, and so you might be familiar with this syntax. It turns out it's no different than, well, hang on. So when you pass in an array into a function in this way, you're simply just passing in the address, not the array itself, right? And so let's go ahead and see what this looks like. So nums, we know that just the name of nums by itself gives us the address. So this is what address? 3000. And so 3000 goes up to array, right? And so this is actually just a pointer. The square brackets is just convenience, so you know that the intent of its usage is being a parameter for a array argument. But you could replace the square brackets with just having a pointer or an asterisk before and without that, right? You could do the same thing. This is just a convenience for C++. All right, so that's identical. Although, I mean, this is more general. This is sort of they're functionally the same, but this provides me information about the intent of this function. I know that I want to pass in arrays into this, despite the fact that it's just a pointer, right? Regardless. And so I pass in 3000 there, and so let me go ahead and declare the array 3000. And so it refers to the same address as nums. And so when I go print out this should be what value? 10, and then this should be 20. That's, there's no mystery there. Fine. So we start out at address 3000, we offset by 0 elements, get the value. We start at address 3000, we offset by 1 element, get the value, which is 20. Boom. Okay, so that's pretty straightforward. I don't think there's anything too interesting there. Well, let's check out this line of code here. Okay, so let's unravel this. Ignore the ampersand. This is doing what? Starting at nums, which is 3000. I offset by 1 element, which is 3004. I dereference that, so I'm referring to this memory location, right? But then what is the ampersand doing? Giving me the address. All right, do you guys see that? I mean, alternatively, I could have just said nums plus 1. That would have done the same thing. But again, whatever. So it is what it is. So this we start at 3000. We offset by 1 element. We dereference it by referring to the square brackets. But then we use the ampersand operator to get the address of this memory location, which is 3004. We pass that into our print array function, or print data. So you can read that, right? So this is where we are. We pass this address into here, move that up here. And so the beginning of this quote-unquote array points to where? Yeah, here, not here. And so there's some implications about what happens when we get to the here, right? So boom. And so at this stage, this array knows nothing about this, right? So when we go down to print out the 0th element relative to that address, what should we get? 20, and then 30. All right, a bit weird, but you guys see the mechanisms behind what's going on here? All right. Boom. And then again, so this is what I said. I could have just said nums plus 1 down here. This will generate the same result as this. You guys see that? Yeah. Nothing. This might be if you want to do some jumping around of arrays. But I mean, this is cleaner than this, right? Yeah. But I mean, I don't know. I mean, I could see this and I can understand. I mean, maybe I might. This, yes, it's kind of tedious because it seems like I'm jumping back and forth, but this does tell me I'm dealing with an array. I'm dealing with a particular index, and I'm dealing with its address. And so I know certainly what's going on by just reading this. This might be, I mean, I'd have to see what kind of parameters going on up here to understand what this is doing. So anyways, so yeah, it can get kind of weird, but just, I think it's just more exposure to some problems with regards to this. You should be okay. Okay, and so let me real quick talk about, I mean, you guys get this. This is the same thing. I think I want to talk about the next thing with the structs, and then we'll get out of here. So real quick, yeah, this is just a short blurb on pointers and objects. Then I'll let you go, right? And so we saw objects, right? And so let me go ahead and declare an object here, right? So we have a nerd. So this is me. I have some number of zits, and I play some numbers of hours of StarCraft. This is my time. You guys probably don't know what StarCraft is. Big in Korea. It's still big in Korea, actually. They still have tournaments and whatnot. So anyways, so I declare a nerd carry. I declare a nerd pointer PTR. What does this look like in memory? Okay, so nerd carry, well, we see that this is a data type that consists of 2 memory variables, and it might look like this. Okay, this makes sense? All right, so there's carry. Carry begins at address 1000. Carry has a memory variable of numzits and some hours of StarCraft played. Right, and then I can also declare a pointer. A pointer is, what sort of things do pointers store? Address. And so it does not look like that. It just looks like this. Just stores an address. And then this line of code has PTR store the address of carry, which is 1000. Boom. And so what I can do, I mean, we know how to deal with carry. I can do carry dot numzits equals 10 if I ate a lot of chocolate, right? And then carry dot hours of StarCraft equals 9,000 if it's the summer, right? And so even though that, I don't even know what summer is anymore. But anyways, I could also do the same thing here, right? We know that PTR is the address of carry. So I go to 1000, I dereference it, which takes me up to carry. And I could use a dot operator like I would normally with carry, right? You guys see that? And so that's how you could use that to use a pointer to manipulate objects. It turns out that there's a much cleaner way of handling this. You already saw that. It's that arrow operator we saw with the previous classroom and students slides, right? And so instead of dealing with this, which is, I don't know. I mean, I know like beauty's in the eye of the beholder, but this is kind of tedious, right? And so this is much nicer to look at, and it sort of confers the same information, and functionally it's equivalent, right? So these two do the same thing. This is, yes, going to the address. This is getting the address and dereferencing it. This is combining all of that, getting the address, dereferencing it, and getting a member thing from it. Okay, so if you have a pointer to an object, use the arrow operator to get member variables and member functions. Okay? So anyways, so that this will set the hours of StarCraft to 42 through this pointer. And notice I haven't done anything with carry directly. So everything was done indirectly through the pointer to carry. And so, again, everything is the same. I could pass in carry into a function called makeover, right? So it's, he has a date, right? And so I pass in the address of carry into this function, 1000, ptr numzits equals 0, so he stopped eating chocolate, and then he can set the number of he cut down his hours of StarCraft to 1. Right, and so this is how you can use this. And so, yeah, I think I'm gonna stop here. Next week we'll get into dynamically allocated memory. But yeah, so really, so I will deploy project 1 tonight, and really there's gonna be a lot of things there that you don't understand. That's okay, you don't need to know any of it. Really the only thing you need to know is the things we talked about in the first half of this lecture in terms of the multiple file etiquette. You can just sort of, I mean, you'll see. Again, there's gonna be a lot of things you don't understand. Ignore it if you don't want to, but we'll talk about it later. Yeah.
You said you were recording your lecture.
Yeah,
Is it like video or audio?
both.
Oh, both.
Yep, video. In fact, I'm gonna stop this right now because we're done, skis.